Dear students, now let me discuss about the next topics of linear differential equation. Here I would like to discuss about the first order linear differential equation. In the last class, as you know, I have discussed about the method of separation of variables. Now let me move to the linear first order differential equation. Let me first tell you what is the form of the linear first order differential equation, and the form is something like this. Okay, so let me take the color first. So the form of the first order linear differential equation is like this: y dash plus py is equal to q, and here p and q are the function of x, where you can write that p is the function of x, as well as q is also the function of x. And here this y dash is nothing but dy by dx. So if you want, you can write it in this way also, that dy by dx plus py is equal to q. Okay, now to solve this differential equation, let me first take that q is equal to 0. To get a very simple equation, let me take that q is equal to 0. Now if you put q is equal to 0, then you will get simply dy by dx plus py is equal to 0. Now if you write it this way, that dy upon dx is equal to minus pi. Now this is separable. So if you separate y and x, so what you will get? You will get just this implies that dy upon y is equal to minus p into dx. Now if you integrate, you will get that ln y is equal to minus integration p dx. Here p is the function of x, so you cannot separate it. Okay, so y will be, and you will get an integrating constant over here. You will get y will be e to the power minus integration p dx into e to the power c. And if you take this e to the power c as another constant, then you will get this y is equal to a e to the power minus integration p dx. So this is the solution of this differential equation, that is y is equal to a to the power minus integration p dx. Now let me take this integration p dx as I. So if you take this I as integration p dx, so you can write this equation y is equal to a e to the power minus I, or you can write that y e to the power I is equal to a. Okay, so now let me solve this equation when right hand side not equal to 0. So how you can find the solution of this differential equation when right hand side not equal to 0? In that case, you have to solve in this way, and before that you can get another equation from here also, that if I is equal to integration p dx, then you will get di upon dx is equal to p. So what we have in our hand, the first thing that y e to the power I is equal to a, and second thing is di upon dx is equal to p. Now let me differentiate this function y e to the power I with respect to x. So what you will get, so if you take the differentiation with respect to x of y e to the power I, then you will get this is as dy upon dx, or you can say just y dash. So it is y dash into e to the power I plus y e to the power I into di upon dx, and this di upon dx is nothing but p. So you will get this y dash e to the power I plus y e to the power I into p. Now if you take common e to the power I, you will get just y dash plus py. Okay, now if you see this expression, this is y dash plus py is equal to q. So you have this differential equation that y dash plus py is equal to q, but this left hand side is nothing but this d dx of e to the power y. d dx of y e to the power I. So if you substitute this value in equation 1, so what you have, we have from equation 1, first equation that we have the differential equation, that was y dash plus py is equal to q, and we can see this y dash plus py. So if you multiply this equation with e to the power I, so what you will get, just e to the power I into y dash plus py is equal to q, okay, into e to the power I. Now you can substitute this expression as d dx of y e to the power I. So you can just substitute this as d dx of, this is nothing but the d dx of y e to the power I is equal to q e to the power I. Now if you integrate this expression, you will get the result. So if you integrate now this, so what you can write over here, it will be d of y e to the power I is equal to q e to the power I dx, e to the power I dx. Now if you integrate this, what you will get, y e to the power I is equal to integration q e to the power I dx e to the power I dx plus c. So this is your solution. This is your solution of this differential equation. So finally what you can write, that y is equal to e to the power minus I into integration q e to the power I dx plus c e to the power minus I. So this will be your solution, and this e to the power I is nothing but your integrating factor. So this e to the power I, that is e to the power integration p dx, e to the power integration p dx, and this is nothing but your integrating factor. Okay, so finally you can write this solution of this differential equation in this form also, that y into if is equal to integration q into if dx plus c. So this is your solution for the first order linear differential equation. Okay, so let me summarize that if you have this kinds of differential equation, that is dy by dx plus p, which is function of x, to y is equal to q, which is also function of x, then the solution of this differential equation, if you have the integrating factor if is equal to e to the power integration p dx, that means you have to find the coefficient of y and integrate with respect to x. The integrating factor will be e to the power integration p dx. Then you have the solution of this differential equation in this way: y into integrating factor is equal to integration q into integrating factor into dx plus c. So you can solve the differential equation with this formula. Okay, now let me solve some question, okay, so that you can understand how you have to use this formula. Okay, so let me solve a question first. Suppose you are given, let me take a question. Suppose you are given that 1 plus solve 1 plus x square into y dash plus 6xy is equal to 2x. Suppose this is the problem and you have to solve it. Okay, so first you have to find out p and q. Here p is 6x and q is 2x, you can see. Let me first rewrite this equation in the form of this first. Okay, so you have to write this equation in this form first: dy by dx plus py is equal to q. So you have to first divide this expression with 1 plus x square. So you will get y dash plus 6x upon 1 plus x square into y is equal to 2x upon 1 plus x square. Now you can see this that your p is nothing but 6x divided by 1 plus x square, and q is 2x upon 1 plus x square. So first what you have to do, you have to first find out I, okay, integrating factor. So what is integrating factor? So this is nothing but e to the power integration p dx. So first let me find out the integration p dx, then I'll write if, okay. So first let me find out that what is the integration p dx, okay. So integration p dx is nothing but integration 6x dx upon 1 plus x square, and if you solve you will get this, just you can 3 into 2x if you take it in this way, that 3 into integration 2x dx upon 1 plus x square, then you can see that 2x is the difference, no, is 1 plus x square, so there is ln 1 plus x square. So we have 3 ln 1 plus x square, okay. Now what is the e to the power p dx, or you can write it in this way, this is ln, so you can write ln of 1 plus x square to the power 3. Now what is your integrating factor? Integrating factor is nothing but e to the power integration p dx, and that is nothing but e to the power ln 1 plus x square whole cube, and that is nothing but 1 plus x square whole cube, okay. So we have if. Now when you get if, then you can solve easily by using the formula that y into if is equal to integration q into if dx plus c, okay. So y into what is our if? If is 1 plus x square whole cube is equal to integration, what was our q? Q 2x upon 1 plus q was 2x upon 1 plus x square, okay. So it is 2x upon 1 plus x square into if means 1 plus x square whole cube dx plus c. So you will get just 1 plus x square will be cancelled out, so it will be integration 2x into 1 plus x square whole square into dx plus c, okay. Now what is the integration of this? You can see this is nothing but, I can write it in this also, that this is 1 plus x square whole square into d of 1 plus x square, okay, plus c, because d of 1 plus x square is 2x. That is if you put a 1 plus x square as t, so it will be t square dt. So if you put 1 plus x square is equal to t, then your integration will be nothing but t square dt. So it will be just tq upon 3, and tq means 1 plus x square. So it will be 1 by 3 1 plus x square whole cube plus c, okay. So your y will be, so this is y into 1 plus x square whole cube. So what is your y? So y will be 1 by 3 plus c upon 1 plus x square whole cube. So this is your solution. And this is how you can solve these kinds of problems, okay, by using this formula, that is y into if is equal to q into if dx plus c. Now let me solve another realistic problem that you have encountered in your radioactivity, okay. So let me solve that problem also, okay. So your question is that suppose radium decays to radon. First radium, suppose your question is that radium decays to radon which decays to polonium, that means it's successive disintegration, okay. This is the problem of successive disintegration, okay. If at t is equal to 0, a sample is pure radium a sample is pure radium, how much radon does it contain? How much radon does it contain? Does it contain at time t? At time t. So this is our problem. Okay. Now let at t is equal to 0. Let at t is equal to 0, n is equal to n0, and which is the number of radium atoms. Okay, so first you have at t is equal to 0, you have pure radium. So the number of pure radium atom, you can say that number of pure radium atoms at t is equal to 0, and n1 is equal to the number of radium atoms at time t is equal to t. Number of radium atoms at t is equal to t anytime, and what we have to find out, that is n2, that is the number of radon atoms at t is equal to t, at t is equal to t. So what you have, first you have n1, first radium decays into radon, and the number of pure radium atoms at t is equal to 0 is nothing but n0. Okay, n0, it is at t is equal to 0. Now it decays to, at t is equal to t, the number of radium atom is n1. So what is n1? And if the disintegrating constant is lambda 1, then when number of pure radium atom decays and the disintegrating constant is lambda 1, then we have from our previous problem that n1 can be written as n0 e to the power minus lambda 1 t. We have discussed this for the separation variable method, that we have our decay equation first, that dn1 upon dt will be minus lambda 1 n1 when n1 is decay, whose at t is equal to 0, the sample has n0 number of atoms, and if it decays to n1 number of atoms after time t, this n1 will be n0 e to the power minus lambda 1 t, and which follows from this differential equation. This is the decay equation. Now what we have, that the rate at which radon is being created. So here radium is decay means what? Radon is created. So the rate at which radon is being created is the rate at which radium is decaying. So n1 is decaying and n2 is created. Okay, so now how you can manage this thing by using the differential equation. So first what you have radium. Okay, so when radium decays, then the rate equation will be du n1 upon dt is equal to minus lambda 1 n1. But now when your radium decays to radon, okay, so this lambda 1 n1 is the decay amount. The lambda 1 n1 is the decay amount, but the radon is also decaying at the rate lambda to n2. Okay, so when radium is decayed to radon, so it is lambda 1 n1, the decay of radium is lambda 1 n1, and this lambda 1 n1 is also the formation of radon, because what you have, radium is the first element, then it will decay to radon. Okay, so first radium decays to radon, that means radon is formed. So radium decays to radon with the rate equation lambda 1 d1 at the rate of lambda 1 n1, because dn1 upon dt, that is the rate of decay of radium, and so radium decays, that means radon is formed. So radium decays at the rate of lambda 1 n1, that means radon is formed at the rate of lambda 1 n1. So radon is formed at the rate of lambda 1 n1. Now radon is also decayed. So if at t is equal to t, it have number of atoms n2, then it will decay at the rate of lambda 2 n2. So the rate of formation is lambda 1 n1 and the rate of decay is lambda 2 n2 for radon. So we have lambda 1 n1 minus lambda 2 n2 is the, at t is equal to time, the radon the rate of decay of radon has this equation lambda 1 n1 minus lambda 2 n2. Okay, so this is equal to dn2 upon dt, dn2 upon dt. So this is, you can get in your radioactivity chapter in nuclear physics. Okay, so let me analyze this thing again, so for your clarity. So first, what you have just radium at t is equal to 0. Radium is decay at the rate of lambda 1 n1, that means radon is formed at the rate of lambda 1 n1. Now radon is also decayed at the rate of lambda 2 n2. Okay, so what is the rate of decay of radon? So rate of decay of radon is equal to lambda 1 n1 minus lambda 2 n2. Rate of formation, actually rate of formation, okay, because lambda 1 n1 is formation, rate of formation, and lambda 2 n2 is the formal decay, so the resultant is the formation. So rate of formation is d lambda n1 minus lambda 2 n2, and this is equal to just dn2 upon dt. So dn2 upon dt is lambda 1 n1 minus lambda 2 n2. Now if you rearrange this equation, that you will get dn2 upon dt plus lambda 2 n2 is equal to your lambda 1 n1, and you can see this equation as your first order linear differential equation. Okay, so now you can solve this linear differential equation by using the integrating factor, because here n2 is the variable, so here lambda 2 is your p, and this lambda 1 n1 is your q. Okay, lambda 1 n1 is your q. So what is the integrating factor here? So integrating factor is nothing but e to the power integration p dt, that means e to the power lambda 2 into t. Okay, so now what is your solution? Solution will be y into if, that means here n2 into if is equal to integration q into if dt plus c. Okay, and your q will be what? Your q will be lambda 1 n1, and n1 is nothing but n0 to the power minus lambda t. Okay, so you have to put this. So your q will be nothing but lambda 1, and n1 means what? n0 to the power minus lambda 1t. So n0 to the power minus lambda 1t into dt into q if is e to the power lambda 2t, okay, into dt plus c. Now if you integrate this, what you will get? Just let me write upper portion. Okay, let me write over here. So what is your equation? Let me take that. So n2 into if means e to the power lambda 2t, n2 into e to the power lambda 2t is equal to n0 lambda 1 into integration e to the power lambda 2 minus lambda 1 into t dt plus c. Now if you integrate this, you will get just n0 lambda 1 divided by lambda 2 minus lambda 1 into e to the power lambda 2 minus lambda 1 into t plus c. So this is your n2. So from here you will get n2. Okay, and if you want to find out the constant c, then you have to put at t is equal to 0, n is equal to n0. Okay, so now how you can find out? So let me solve this thing also. Okay, just wait a minute, let me erase this. Okay, so now if you take e to the power lambda t in this side, let me first put that at t is equal to 0. So if you put t is equal to 0 over, then we will have n2 is equal to just n0 lambda 1 divided by lambda 2 minus lambda 1, e to the power 0 is 1 plus c. Okay, t is equal to 0, n is equal to n0. In fact, at t is equal to 0, n is equal to n0, but n2 is equal to 0. Obviously, n2 is equal to 0, so left hand side will be 0. Okay, so you will get c from here. That will be minus n0 lambda 1 divided by lambda 2 minus lambda 1. Now, if you put here c, then you will get the expression. This expression will be something like this: that n2 will be lambda 1 n0 divided by lambda 2 minus lambda 1 into e to the power minus lambda 1t minus e to the power minus lambda 2t. This will be your final expression. Okay, thank you.